Today's presenter is Lucidworks Technical Enablement Manager and Lucene Committer, Andy Oliver. Thanks for joining us today, Andy.
Thanks, Leah. So today we're going to talk about conversational search with Lucidworks Fusion, and this presentation is going to be a little bit different than the one we did last time. So last time we showed a very, hey, in an hour, get your search done, get your site done, have your signals, have all of your collaborative boosting and all that kind of stuff going right out of the box. This week we're going to show something that's a little bit more forward-looking, and that you can use at the same time you can use some of these technologies and make it happen today, but it's not the same level of immediate feedback as last. This is bleeding edge or cutting edge kind of stuff that we're going to be covering today. Before we start that, though, for those of you who've not joined us before, a quick introduction to Lucidworks. It's a San Francisco-based company with people all over the world. We are behind the Fusion product, the Lucidworks Fusion product, which is a search product built upon the Apache Solr project. Apache Solr is an open source project, and we actually back 40% of the active committers on the project and have contributed over 70% of the Apache Solr code base. Solr powers our product Fusion and is the source of a lot of its power, but we go above and beyond that and make it more operational and a little bit more efficient to develop on. Our product, Lucidworks Fusion 3, was just released. The 3.0 version was just released about a month ago. And one of the things that our product brings to you that goes above and beyond just what you're able to just grab from open source is over 50 connectors to get the data. So it's great to have a very powerful search engine, but if you can't get your data into the search engine, well, that's a problem that you've got to overcome with a lot of custom code that you've got to write and maintain yourself. That's fairly costly. The next thing is that data transformation. So great, you've connected to your data source. Can you parse the data in the format that it's in that data source? So we have a parsing framework that usually one of the things I found that was interesting in developing some of the training is I had a really hard time demoing why you would go and care or configure this thing, because most of the time it just works out of the box. I had to find some more esoteric examples where you would actually have to go change what the parsing framework was set up. But if you come up with more esoteric data sources or data formats, you're able to configure this or even develop your own parsing stages and plug it into our framework. Our system is built on a UI that's point and click and easily maintained. And one of the things that I find interesting, I'm a fairly new employee to Lucidworks and have worked in a lot of different data integration projects. And I've worked with a lot of different ETL tools, extract, transform, load, the tools that pull data from one place, transform it, and put it somewhere else. And our product actually has one of the best ones I've actually personally experienced. So being able to take that data from a connector, transform that data, or parse the data in a format that can be read, and then transform that data into a format that's useful for indexing the data and searching the data, those are all key things that our product enables and automates and makes more operationally intelligent. Additionally, in any kind of enterprise situation, you're going to be concerned with who's accessing the data and whether they're allowed. So a security model that is able to connect to your Active Directory or whatever your SAML-based services or LDAP server, and be able to say, okay, this is the user, and then say, even go so far as to, if you're indexing, say, SharePoint data, using your SharePoint ACLs to say, oh, this user's not allowed to see this, so let's trim this out of the search results. So you need a robust security model in any sort of enterprise and even retail sort of search situation to make sure that that people are allowed to look at what they're getting back. We don't want to show the user a bunch of search results they can't even click on in many situations. And this is all built on a chain of responsibility pattern. So our product has two different main pipelines. We've got the index pipeline and the query pipeline, and this is a chain of responsibility pattern. Each thing has stages that work on different aspects of the data. You can plug your own in, you can configure them, you can add regular expressions. Heck, you can write a JavaScript stage. You can use our JavaScript stage and write some JavaScript that does whatever funny thing you want to do to the data. Yes, you could build all this on your own, but would you have a good operational way to manage all of these index pipelines and stages where collaborators such as your system administrators and search administrators and what have you are able to say, hey, I know what's wrong with the data. This thing here is misbehaving and changing the data in this kind of way. If you look at the new product, Fusion 3.0, you'll find the query workbench. You can actually make changes and watch the changes without running the whole process, as well as you can do this in the index pipeline or the index workbench, which is even more powerful. So if you're about to do some complex data transformation, you want to make sure that that's really going to do what you think it's going to do before you run the whole index process. You'll be able to visualize it in an attractive UI. And this is all about bringing operational simplicity to the complex problem of data ingestion and search. So Fusion, our product, is built on a number of different technologies and a number of different open source projects. At its core, as I mentioned, is Apache Solr, but we also use Apache Spark for some of the distributed computing aspects, as well as our product enables you to use machine learning and other types of analysis on your data, analysis and transformation on your data, and those all come from the power of Apache Spark. Additionally, for cluster management, to be able to scale and configure your search cluster, you need we use Apache Zookeeper. This is all built into a platform for us, so we actually remove the complexity from you having to manage it, and so you see just the part. I mean, you can still access it, but you mainly focus on the part that's part of your search application and part of your data transformation and query pipelines, as opposed to managing all of the different bits and pieces that typically go into a cluster search. So Fusion brings together your entire search and analytics platform. Everything's exposed via REST API, so everything you can do through the GUI, you can also do through a REST API. That's a HTTP API that speaks and receives JSON. You can also use XML. And then there are security policies that can be applied to all of the data out of the box and can be configured to connect to your different security providers. This is all distributed. It has fault tolerance. It can scale. We can even do WAN replication, so if you're going to multiple different data centers. And this is all something that your administrators and other collaborators beyond just the search developers will be comfortable working with. So with that said, we're going to get right into the meat of building conversational search with Fusion 3. First off, let's define conversational search. So conversational search, in its formality, is this ask and answer, right? So if you go into Google now and you click the microphone button or you type in what's the temperature, and it responds back, today the temperature is 80 Fahrenheit or what have you, then that would be an example of conversational search. Going towards the next step, it might ask a follow-up question. Hey, I couldn't tell what region you're in. Do you want that in Celsius or Fahrenheit? Or ask a follow-up question to get you the exact result that you want. This sort of a very rigid definition of conversational search can be a bit overbearing, because there aren't as many in business of these simple ask and answer. A lot of times, if I say what are my sales numbers for last quarter, well, what do I want? Do I want revenue? Do I want profit? Do I want that by region? So there's going to be a lot of other data that might be supplied, and yeah, it could ask me what part of that are you interested in, but a lot of times giving me the 5 or 10 reports that are most relevant is a better answer than an English, than a purely English answer. So we're going to really kind of not be real rigid with our definition of it, but that's the overall formal idea of it. Part of getting the conversational search is going along the path that the Fusion product as well as the overall solar community has been going through the past few years. So to begin with, to get to conversational search, first and foremost, you need a path to better search. Part of that was better query parsers. So when we started out with in the solar sort of community, you had the standard query parser, and the user, or at least the search application developer, had to do a lot of smart to get the right fields involved in the search and construct a search that made some sort of sense in order to get the sort of results that you wanted. The next thing is similarity, more like this. A lot of when we communicate with each other, if you ask me to explain something, a lot of times I'll say, well, it's like this, but here's a difference, and here's how it extended, or it's like these two things. So similarity is a key piece of this, more like this. Collaborative recommendations, which I touched a lot on last week, basically as users pick results, those results get boosted or recommended to others. And one of the things that I'm going to be talking about in 2 weeks or so is at the next webinar is personalization, giving users results that are more tuned towards their interests. So these are all components of better search, and getting conversational search to work is really, these things are prerequisites, because if Google comes back and tells you, I don't know what temperature is, then that's not helpful to you in the terms of a conversational search query. So figuring out how to get that better search is the key before you even go there. When I talked about the better query parsers, we've gone from the standard query parser to being default to the disjunction max parser, which is all around being able to take English phrases and things and then apply that to fields and get the best score overall, as opposed to scoring each separately and adding that together. Instead, we now get the best overall score for the relevance of the document. I talked about more like this in similarity. So this is part of the Fusion pipeline. You can say, I want more like this, and supply a document ID as the search parameter, and it'll find you other documents that are similar to that. And this is done on an algorithm that we used to use a simple term frequency algorithm. Now we use an adjusted one that has a saturation point. And the saturation point is basically that if I've got a phrase mentioned 10 times in one document and 100 times in the other document, maybe the other document is more relevant, but just because it mentions it 100 times, is it actually 10 times more relevant? Probably not. And the length is a factor, but is that really the be-all, end-all, the overall weighting of the document, the number of mentions to the document length? So at some point we have to sort of saturate those out and say, oh, these two documents both have sort of crossed that threshold. This one's not 10 times more relevant, it just has it 10 times more often, and this one's a lot shorter, and it mentions it more in proportion, but we've gotten to the point where that document is, short enough to where it's not that much more relevant than the 100-page document that's all about that thing but only mentions it linguistically 5 times. So it adjusts it and sort of straightens out the typical term frequency, inverse frequency algorithm to be a bit more intelligent. Next, we have this, as I mentioned last week, 2 weeks ago, the collaborative recommendations. These are based on Fusion signals. These are built right into the product. If you use it with Vue, it's even built into the UI that you develop. I demonstrated that in the last webinar, which you can watch on YouTube, or you can go to the Lucidworks site if you don't feel like typing in that nice long URL. Recommendations work because users initiate searches, they select results, those result clicks are captured those captured clicks are aggregated. Those boost individual results for those searches, and so the next time someone initiates the same search, the results that frequently got clicked are closer to the top. Personalization goes to where signals are on a more per user basis as opposed to doing it on the basis of just a search. I'm going to boost things that I personally click on often. I may boost results that are like the ones that I've clicked on, and I'm going to talk more about customer targeted and personalized search in the next webinar. So let's get down to the brass tacks of really conversational search is all about language. The first sort of easily lowest hanging fruit form of more natural language search is a more domain-specific language. And what that means is basically what is natural language, or what sounds like natural language to a derivatives trader, or what's plain English to a derivatives trader is not plain English to me necessarily. When they start talking about different credit default swaps and all these different fund to fund and all of that good stuff, and quants and so on and so forth, that's a language that's deeply meaningful to them and to their systems, but it's not necessarily deeply meaningful to the general public. So creating sort of a search that is more based on a domain-specific language is incredibly useful in an enterprise search scenario or a domain-specific search scenario, probably more so than and more accurate than natural language search. And we see that with autocorrect or different things like that. If you work in a specific field like finance and what have you, and your phone comes out of the box and starts autocorrecting when you're texting a colleague, you'll find out that it just doesn't autocorrect for everyone else, doesn't work that well for you, because you really did mean PE ratio as opposed to whatever it would autocorrect that to. So domain phrases and then entity tagging are core to this. So having those sort of domain phrases searched and parsed, and having the entities recognized and tagged are key to a domain-specific search. Spoken language is the hot stuff. At Revolution, our CEO quoted that I think it was something like 20% of search was now this sort of speech or natural language search. Speech to text is sort of the hard part of it. Text to speech, there have been libraries that do speech synthesis and things like that since, since the 80s or what have you. So mainly the latter comes out to be a lot more UI, where the speech to text comes out to be both sort of a collaboration between having the right speech to text library and language corpus and machine learning and different aspects of that go into making more accurate speech recognition and speech to search tuning, whereas text to speech and the answer you get back oftentimes is a lot more UI. Then we get down to, okay, now we've got domain-specific search, we've got speech to text. Then we get down to where we start having the thing respond back to us. These have taken some interesting forms in the last, some of the more interesting ones have been political, so I'm not trying to get political on you folks here. It's more that some of the more interesting corpuses and interesting things that have been happening have been political. So the first off, we'll talk about a little bit about this Donald bot. We'll talk about Alexa, and we'll talk about the machine learning aspects of this, taking a very unique language corpus and being able to synthesize interaction from it, the Deep Drum project from MIT. So the Donald bot was put out by a company, and it basically takes the personality of a pushy sales guy. So if you want to check it out, it's part of Facebook Messenger, or you interact with it with Facebook Messenger, and it will talk to you, and basically it'll talk to you about stuff, but ultimately what it's trying to do is sell you a notated copy of the Constitution of the United States that been annotated by Mr. Trump. So, but it's sort of a pushy sales guy bot that just sort of talks back and forth to you. This isn't really all of that sophisticated. It's more of a dialogue. It does react to things that you're saying, but it's sort of got limited reaction to the things that you're saying. We also have the more sophisticated things like Alexa, Cortana, Google's Assistant. These are really speech-to-text connected to a search engine with a UI answer, or with a answers UI. Then we've got Deep Drumpf. So if you go to Twitter, you can look at Deep Drumpf. I actually did sort of censor one of the things that it says, so where it says potentially offensive comment. That was just removed by me for this webcast. I couldn't find a set that didn't have something that was a little whatever. So I removed that, but you'll get back as people interact with this Deep Drumpf, or as it interacts with Twitter, it takes things and then responds to it based on a corpus of speech that was pulled from Donald Trump's Twitter feed. And so it tries to respond sort of in the style of Donald Trump. So this is an easily sort of accessible example. You can also read about the research that went into it with neural networks and how it learned to talk like this. And so while this stuff is, this is sort of a almost silly example, you can also apply it to specific domains and get more tuned answers to user questions and giving the impression that the computer is a person answering them, and in the style and in the domain of that search. Another thing that we've been working on is OpenCal, which is aimed at the finance market. So you can go to opencal.org, and it does tagging, entity tagging. What we end up with in Fusion is a very faceted search that, from a set of documents and corpuses, or from a set of documents, it finds, this document mentions Google, this mentions the stock price, this mentions PE ratios, this mentions these various things. So based on that, it then is smart enough to go out, and when we ask for very specific results, it'll give us, in the domain language of the finance community, it'll give us back results that are tuned to that. Where if I were to use just normal search, then it finds me just documents that mentions PE ratios and 5, where I'm really looking for stocks with PE ratios above 5. And so I'll demo that for you guys real quick. So I can ask for stocks. I can ask for specific companies, staples, and this was mentioned in my my corpus. I can also, you see that it scanned these documents and it automatically identified what are essentially facets, as well as the sector, which are again facets, and it identified the companies that are mentioned in the particular set of documents that I indexed. I can also say stocks with PE ratios less than 5. And I'll get back stocks with PE ratios more or less than 5 based on what I put in as my feedback, and it'll show me the PE ratio and the value. To make this work, we actually go out and call to the OpenCal service, and it's basically a web service call. We post the content as part of the overall Fusion pipeline. Entities are identified, events, industries, and so on and so forth in the content, and then we get back a schema that from any any of the stuff that we're getting out of Tika, PDFs, HTML documents, etc. We get back content that that has those things faceted and tagged and so on and so forth. So it looks like a very natural language to stock traders, where they just enter in the domain language that they're familiar with. On the front end side, this is using some of the overall some of the overall Fusion JavaScript stage and so on and so forth to do some minor manipulations of the data that come back. The next thing that I think is highly interesting in this area are speech-to-text enabled search. This is plugged directly into Fusion query pipeline. If you just were doing Fusion and you didn't have a UI in front of it, you can basically post a wave file to the REST endpoint. If you've got a front end, then obviously you'll handle how the sound is captured on the front end and then post that to Fusion. But we announced this partnership with IBM Watson and integration into Fusion back at Revolution in October. It's a stage plugged into Fusion query pipeline, and you're able to just talk to it and say, hey, this is what I want back. I'll demo that for you guys real quick. So I didn't plug this into the together, so it's just going to pull you back similar results. It's not doing the actual domain language for this because it's a different UI. Stocks with PE ratios above 5. My laptop is a bit on the slow side today, but we got our speech recognized. If I were to plug this into the same pipeline as before, it would have done a bit smarter job, but it found these keywords. This is also a demonstration of why natural language search isn't always the best search. Sometimes that adding that domain language intelligence is incredibly useful. I got back a series of documents that I can look at from my corpus, and I did that with speech. That again is plugged in via the Fusion query pipeline. So we have the Watson speech-to-text search, and that is something that you can go and request from Lucidworks website. And this connects out to the IBM web service, the IBM Bluemix speech-to-text service, and is able to convert the speech that we give it into text and plug that directly into our search pipeline. It basically takes whatever you said and adds it to the query string as the queue, which is the query to Solar, and then we can do any of the other sorts of things that we do with a search using Fusion pipeline stages to manipulate it. When we go more towards that very interactive search and we start looking at machine learning and what have you, and this is really an R&D sort of project at Lucidworks, we have what we call the RTFM bot, which is the Read the Funny Manual bot. Basically a lot of times questions get asked on Slack or what have you that one could have easily just typed into Google instead and it was the first result, or typed into the lucidworks.com website where we have a Fusion-backed search for our documentation and would have gotten the exact same answer versus making someone else answer it for the 1500th time. So a little bit of a cranky thing to create, but hey, you know, we're developers here. So it's based on the Chatterbot. It uses the natural language toolkit, Python natural language toolkit. You can train it on a set of Slack results, and it answers questions generally with Lucidworks Fusion search results. I didn't want to give a live demo of this because it would pull back internal stuff from our internal stuff as well. But this is showing typing into a Slack channel how to set up Solar, and it gives us back search results from our Lucidworks Search Hub, and says here's basically the things that you should just go click on, as opposed to asking that question in here. So without further ado, we have time for questions. And again, the next webinar on March 15th will be about building customer-targeted search using Lucidworks Fusion. And I look forward to talking to you guys then. So do we have questions, Aaliyah?
Okay, so we do have one question so far, and we're waiting for a couple more to come in. So the first question was, someone was asking about where you said the IBM Watson query pipeline was available. Are you there, Andy?
Oh, sorry. Can you hear me now?
Yes.
Okay, good. So that if you go to the link that I posted on the slide, or just go to our website and search for Watson's partnership or Watson speech to text, it should come straight up for you.
Okay, thank you. The next question is, can you show us the PE ratio query results again? Did it really find results that matched?
Sure. All right, stocks list PE. Hey, you know what? You caught me. It's that first. Okay, there we go. It's actually reversed. So this was working yesterday. What can I say? A demo is always a demo. So today it seems to be showing me a set of results that are boosted. Okay, here's what's going on. This has been boosted to the top and it's ignoring my query. You know, there are many ways one can torture themselves, and the best way to torture oneself is to do a live demo. So right now it's not working. It worked yesterday when I tried it, and today it is not working. This is actually an internal service of one of the other developers must have hit this for me, but it does work normally, and it works by basically this field PE ratio has been faceted out, and it maps this term to a field search on this through the query pipeline stage. But today you caught me. You saw it. It is not working right now.
Alrighty, thank you. The next question is, how does query intent play into the bot scenarios that you discussed?
Sorry, the question was, how does query intent play into the bot scenarios that I discussed?
Yes.
So there are a lot of different interesting ways to sort of construct that. What these generally come out to are a really sort of sophisticated search parser or a query parser combined with, at times, a machine learning corpus, sometimes a neural network, combined with a search engine. As far as specific query intents, most of the bots that I've shown today are a little bit more primitive than that, but that is a good approach, meaning if you really sort of want to start customizing the results, that's going to be a key part of how you do it versus just having the bot learn overall. A bot should really sort of learn more from more how to interact with that individual person. But we're a little early on in this sort of development. That Donald bot just came out last year, and it's pretty primitive. The Deep Drumpf again came out last year, and it's sort of one of the earliest examples of it's actually sort of an example of a domain-specific neural network bot. So at the moment, not much, but you're exactly right. That is the direction it should go.
Thank you. The next question is, can you please walk through the business logic query stage in the TRIT solution query pipeline? Is it a JavaScript stage?
Yes, it is, and it's super dumb what it's basically doing. So it's basically taking the query, removing the query and adding it to a new query. So it's not doing anything particularly smart. It's seeing if the query starts with a quote and ends with a quote, and if so, it's basically removing the quotes and removing the previous query parameter and adding it with the query parameter unquoted. From there, it does some simple boosts and what have you on some parameters. From there, it's a weighting. It's basically just weighting a field, and then from there, it's boosting based on subquery results that come back.
Thank you. The next question is, how can the Lucidworks product Fusion help in the creation of chatbots, say, for customer service?
That's a great question. So there's a few different places that we can help. So first off, you're going to need to do this for customer service, you really need some sort of search result in the back end. So you need a search engine in the background, and you need to be able to tune the kind of results that you're getting back. Yes, you're going to use various techniques on the sort of front end, but you really have to do this in combination. So on one hand, the chatbot is going to be essentially issuing queries, and you want to make those queries work better for the chatbot as much as you want to make the chatbot make better queries. So that's part of it. You need to be able to scale out this solution for a customer service agent, and you need to be able to manipulate the data appropriately. Aside from that, our product, and we don't have a great amount of time to go into it now, our product does have machine learning pipeline stages that you can use out of the box in different ways to apply models to your data. Those are all helpful ways to get back better results, especially in combination with machine learning techniques.
Thank you. How do Q&A systems work in general, and how is search making them easier?
So a lot of the existing Q&A systems are pretty simple. They basically are a sophisticated query parser that just return back search results. So most of the existing Q&A systems are outstandingly simple. The next stage of them, though, is making sure that you've applied tags to the data, make sure that you've created facets based on parsing in the data at the index stage and identifying from those different results, from those different answers that you have that, gee, take the last one I interacted with, cable modem, router, etc., and that you've identified the models, and gee, this might have been a free-form text field when the service tech typed it in, or the customer service agent or whoever originally created this result typed it in, or it may have come from manufacturer's documentation and so on and so forth. But to make a useful result, you've got to do more than simple search on the body. You want to actually limit the search to the model. You want to limit the model of cable modem, or that it's a cable modem problem, or that it's this particular type of network problem. So it's about pulling out those domain-specific entities and results, making a model of your data or making a schema of your data that creates reasonable searchable fields based on those. And these are all things that you really need something like the Fusion pipeline to do well. And then on the front end, you're always going to be tuning this query. You're always going to be tuning it to be better. And tuning it to be better is a work product, and it's something that is difficult to do if you have to actually run through either the index or the search process and can't see what you're doing until you run through it. So using the Fusion query workbench and index workbench is an excellent way to do that, and it's sort of a critical way to do that and get back better results.
Thank you. The next question is, I am thinking of using the Solar Learning to Rank plugin for machine learning. Is there an out-of-the-box integration with Fusion to the Learning to Rank plugin?
That's a great question. I'll have to get somebody, I'm not familiar with that, so I'll have to get somebody to get back with you on that particular question.
Thank you. Is it possible to set up a central logging platform with Fusion?
Absolutely. So Fusion supports, absolutely there's a few different ways. So hold on, Leah, did you say login or logging?
Logging, and the person also said as an alternative, okay, cool, for the elk stack.
Yes, you can. There are plugins that work with the query pipeline that you can plug in other stuff. I actually have a demo as part of the Fusion training that actually parses Apache logs and shows them using our sort of answer to Kibana, which is called Banana. It's basically a fork of it that works at the Solar level. So yes, you can, and I'll post a blog post just sort of giving you the how and what for, demonstrating it with an Apache style log and demoing getting out charts and analysis from it. I actually do that as part of the Fusion training. Great.
Thank you, Andy. So that's all the questions we have for now. Everybody who registered for this webinar will receive a link to both the recording and the slides in the next couple of days. If you have additional questions that come up that you didn't get a chance to ask, please feel free to send an email to events@lucidworks.com. Thank you for joining us today. Thank you, Andy, and we hope you have a great day.